Hello, welcome to the Illinois Space Society's Human Spaceflight pre-recorded video. My name is Courtney Leverenz, and I'm going to teach you about the tools astronauts can use in space. These tools that are going to be talked about here were designed for the NASA Micro-G Next Challenge that Illinois Space Society participates in each year. Let's learn about these tools and more. What are tools per se? Most people tend to think about tools you would find in the shed, but in reality, you use tools daily. Can you name a few? I'll give you some hints. What do you use to brush your teeth? A toothbrush. How do you eat your cereal? With a spoon. Last but not least, how do you comb your hair? You can actually use two different tools, a brush or a comb. See, you use tools every day to complete tasks. Well, astronauts also use tools to complete special jobs as well. These tools can range from brushing their teeth to repairing a solar panel. Tools are designed and developed to complete tasks efficiently, as well as also having them to be easy to operate. Our members had to keep these 2 points in mind when designing tools for astronauts to use. Where we designed these tools for was for the NASA Micro-G Next competition that college students participate in. This competition is hosted at the Neutral Buoyancy Lab at Johnson Space Center in Houston, Texas. There, we design, manufacture, and test tools to complete different challenges NASA needs to solve. If the astronauts and divers like the tool, it can be selected to travel to space to be used on the International Space Station or someday potentially on the Moon or Mars. Let's dive in to learn more about these tools. Our first tool is the Modular Asteroid Chip Sampler, or MAX. This tool was used to chip a sample from a large boulder and capture the sample in a cage to bring to the surface. It kind of resembles a harpoon gun where the dart would shoot from the case after it was cranked and fired. Pretty cool, right? Our next tool is ALMA, which is the Adaptable Low-Cost Modular Anchor. This tool could be used as an anchoring device that would go on the surface of a planet or an asteroid. The goal of it was to hold 15 pounds without movement, which in fact almost surpassed this goal by actually breaking NASA's scale and holding 50+ pounds. That's pretty heavy. Let's watch the footage from the MBL to learn how ALMA works.
For this first test, go ahead and match it to the number 3 mark. It will be the lowest mark on that shaft.
Your marks are gone.
Oh, okay, I see that. Go ahead and anchor to about 6 inches below the double point, or about 2 inches above the auger.
Copy.
So as you can see, ALMA was twisted into the sandbox as a way to kind of put the force of the tool to be able to hold something that's heavy, such as a rover or something else that the astronauts don't want to lose when they're in the microgravity of space. Our next tool is called SPORT, which is the Station Puncture Orbital Repair Tool. This tool was designed to help repair micrometeorite and object debris, which is also known as MMODs, which then produce holes on the International Space Station. They're little, so don't have to worry too much. But this tool relied on rubber stoppers to seal the hole. Let's check out how this tool works.
Same as before, give that handle a quick tug to ensure that it's secure to the rod. All right. Go ahead and line it up with the hole and push it in.
For your essay, I have the tool now in my dominant hand, and we're in my non-dominant hand.
Roger that.
All right, first half clear.
Okay, we're going to use a different number of turns.
So how this tool works is the astronaut would take the wrench and twist the nut down to compress or expand the rubber stoppers. If you ever played with a marshmallow and squeezed it, you notice that on the sides it gets a bit puffier. And that's how our tool worked. Go to the next one. Our first tool is called MIDAS, which stands for Micrometeorite Impact Detection and Suppression. This tool's job is to detect and cover sharp edges on the International Space Station that result from MMODs. Similar to the thing above, we have to protect our space station so the astronauts can easily live up there on a daily basis. So this tool would detect sharp edges through Velcro and cover them with tape. Our final tool today is Lunar Exploration Tool, or LETO, which is actually named after the mother of Artemis. Artemis is the Greek goddess of the hunt, which is actually the theme of NASA's new mission. LETO collects and contains samples of lunar rocks. LETO actually just finished testing at the MBL and performed awesome. Let's see how it works.
Off the moon so that astronauts don't need to lean over and pick up rocks like this. On the lunar surface, there's dirt called regolith. Regolith is really sharp and abrasive, and it gets everywhere and it covers their suits. So what this tool is supposed to do is limit the amount of regolith that the astronauts get all over their suits. Here's how it works. You just hold the tool, and you're able to see right under a rock and completely capture it. No extra regolith. Now our astronaut can bag it up and send it back to Earth so the scientists can analyze it further for science.
Now that you've learned about some of the tools ISS has designed, it's up to you all to help solve NASA's future challenges. Thank you for tuning in and learning about Micro G Next. Thank you.